Let's start our first class. This is what we're gonna do today is briefly go through the syllabus. Mechanics of this course is what you need to notice, what you need to be prepared. And we're gonna go through the schedule a little bit and some introduction. So basically, hopefully we can end it in 1.5 hours if possible. So this class is microelectronics. I think this is the fundamental course that you're going to take when you start understanding integrated circuit or integrated circuit technology, either technology or circuit design, the basis of circuit design. So this is the most course, I think the first fundamental course, I think, in electronics, microelectronics. So general information, of course, we'll start by introducing who I am. My name is Xiaqing King, and that's my Chinese name. And my office is at Delta 820, and there's the contact information. So the best way to contact me is by email. So if you have any problems with your courses, you want to make an appointment to meet with me in office hours, like I said, I have regular office hours. We'll talk about that later. But the point is that if you have any trouble in this course, any concerns, please email me and then we can make follow-up arrangements. And next thing is office hour. I will hold regular office hour before class every Tuesday from 9 to 10. So you can come into the office and ask me any question regarding your learning process or whatever. Okay, so you can come back, or if you cannot make it at that time, if there's a conflict in schedule and you still wish to meet with me, you can always email me and make appointment for some discussion. And classroom, there's no problem, is 217. And our class hours are Tuesdays and Thursdays, starting from 10 past 10. So make sure that you come in time, don't be too much delayed. Otherwise, you'll disturb other people's learning process. And we have two teaching assistants. One in the back is Wang Yaqing. The other one is in the front for recording, Liu Zhequan. So if you have any questions, you can also email them to make arrangements, especially on quizzes, homework, that sort of problems. And then their contact information is also by email, and also I think there's a phone number. I think I missed one note. That should be 107. 是107吗? The extension. Yeah, I think I missed one note. But anyway, I think the best way to contact them as well is by email. And they will also have regular office hours, and it will be announced on EE class. Is everyone familiar with EE class? Are you all signed in? So we will make announcements, and we also put materials up in EE class, homeworks and answers to quizzes, that sort of things on the system. So make sure that you're assigned and make sure you're notified on the system, through the system. Okay? So this class, as I said, is the fundamentals of microelectronics. So this is the first basic courses on microelectronics. And the textbook we're going to use is this one. You can see the cover on that. That's by Razavi. He's a professor at UCLA. And this book has been, I think we have used this for like more than 10 years. So this is the third edition. I would encourage you, because it is a fundamental course, so it's probably good to get a hard copy for reference. So if you really want to invest something in a book, this probably be a good one to have. So this is the fundamental of microelectronics. They come in the third version, so third edition. Okay? So any other questions? So basically what we're going to talk about, these are the key topics that we're going to discuss throughout this course. I would say that if you ever taken courses like 电子学 or microelectronics, it used to be when I was in college, okay, it was a few years back, and you usually take courses in 3 sections. There's 电子1、2、3. There's three semesters. You take microelectronics in 3 semesters. So you have 1 semester is on the introduction of circuitry and the elements. For example, semiconductor. You spend most of the time talking about device physics, a little bit on devices and simple circuits and circuit analysis skills and that sort of things. And then the 2nd semester, you start to dig into more details on analog circuits. And the 3rd semester will be on analog and digital circuits. Nowadays, we sort of make electronics 1 and 2, make it into 1 courses. So therefore, there's a lot more contents than a single semester courses. That's the reason why, even though this is a 3-credit course, we give you 4 hours of lectures because there's many more to go on. So we're going to start by, of course, talk about some semiconductor physics because integrated circuits are made on semiconductor wafers. So we're going to talk about semiconductors. Why are we using semiconductor devices? There's pros and cons, and there's the features of these particular materials that allow us to make transistors. And why does the function of transistor, there's carriers of different type of carriers, electrons and holes, that sort of things. So these are the basic ground rules in understanding how these fundamental elements, how do they function. And then the next thing, we're going to start with simple circuits, the most simple circuit that you can come about if you use the most simple device, which is a p-n junction. That's the diode. So we're going to talk about diode and diode circuits, its applications, and how does one. We're going to also cover some sort of rules as to how does one analyze circuits. So these are also very important guidelines that allow you to move along into more complicated understanding of circuits or analysis of circuits. And then we're going to talk about transistors. So you start with basic understanding of the physics of semiconductor. We're going to talk about p-n junctions, and then next we're going to talk about more complicated elements, which is a transistor. So how does the transistor functions, different type of transistors. There's basically 2 types of transistors we're going to introduce. And of course, these 2 types of transistors will then lead to different analysis on its corresponding circuits. So we're going to talk about transistor physics and also circuits. So there's amplifying circuits, and then we're going to talk about circuits. How do you analyze these type of circuits? So we deal with 2 typical problems with circuits. One is the speed of circuit, meaning bandwidth of your signal that we can process. And the other thing is how do you deal with noises? So that come by with a discussion on differential architecture. Okay, so okay, everybody following me? Okay, good. So I need some responses from you. As I said in previous classes, I would encourage everybody to answer questions or ask questions, but I seldom get responses. So this semester, I want to try something. So if you ask a question or answer a question, after class, you can come up and I'll give you a sticker. So you can collect the stickers. It's like 几点这样的. You can collect the stickers. So what I have already promised previous class students is that if you like, I will actually do some tally at the end of your stickers. So if you're at the top, I don't know how many people will ask questions. So we're going to make sure that you're within maybe top 10 of the people who ask questions. Then at the end of the grading session, if you only need a few points to get to the next grade, then you can come back and show me your stickers, and I will consider. Okay, so if you collect more stickers, then I will consider to allow you to do some minor adjustment at the final grade to make sure that you can have a better final grades. Does that sound clear? Okay, so that's the plan to encourage. Yes. 什么事情？ Yes, yes. 如果你想要用中文问也是 OK. But I want to encourage you to ask your questions in English. So I'm going to give you 2 stickers if you ask your question in English. So the problem is that we have foreign students in our class. So as I said Can someone help me close the door? The door. Get the door. Okay. So because we have foreign students, I found that it's probably unfair if we do discussions in Chinese. So I think in previous semester, some of the students asked me to repeat some of the things I said in Chinese, like very short summary. But because we have foreign students in the class, I probably want to avoid that as much as possible, because I don't want them to feel biased or unfair. So please be considerate because we have to accommodate foreign students. Okay? Is that okay? So any questions is fine. If you want to ask answer questions or ask questions in Chinese, that's fine. Okay, so you can still get 1 sticker. If you ask question in English, I'll give you 2 stickers. Okay, would that be good? Any other questions regarding course mechanics, that sort of things? The thing I want to mention is that if you find it problematic following my English or the progress of this course, we have another course which is offered in Chinese if you really have that problem. And so you could always go to the other course. And the good thing about these 2 courses is that, 2 classes is that I have already aligned with Professor Huang that we're going to follow the same schedule. We're going to have the same quizzes, same homework, and same final and exams. So we're going to follow the same schedule. The quiz, exam, and homeworks will be identical. It's going to be the same, okay? So if you ever wanted to transfer to a Chinese class, it's perfectly fine, but you want to do it as early as possible. So as I said, we will have all I want to emphasize once again, the homeworks, the quiz, and midterm exam will be identical for the 2 classes. For students in both classes, it will be identical. So, so we're going to have mostly, there's 4 things you need to do. One is, of course, homeworks. We don't have many homeworks because we want to focus, the homeworks will be mostly simulation based. So make sure that you have some rudimentary or preliminary contact with the simulation tools. So that's mostly SPICE, whatever type of SPICE. But the homework part will be actually prepared by Professor Huang's teaching assistant. So if you have any question, you can ask them. And our TAs will be responsible for the 6 quizzes. So we're going to prepare quiz problems. We have 6 quizzes arranged, and it will be held on Thursday. I think every other week, about every other or every 3rd week. We have a schedule up, so don't worry. Just make sure that if you miss classes, it's probably fine, but you want to make sure that you come for the quiz, because quiz will take up 30%, so it's a lot. So make sure that this is mainly to make sure that you follow up on the progress of this class so that you won't wait until midterm and do all the cramping studies and stuff. And then we're going to have midterm and finals. So maybe Professor Huang and I, each one of us will be responsible for preparing the exam questions. Okay? So these are the range that's going to cover for the midterm and the finals. And the exact time and date, exact time will be announced prior to the exams. So this is the final schedule for the class. So you will see that we'll have mostly quizzes almost in a bi-weekly fashion, but we have it all scheduled up. And the homework, what type of simulation will be involved, including diode circuits, single-stage amplifiers, amplifier simulations, and frequency response simulations. So those are particular things you need to be able to deliver and familiar yourself with the simulation tools. So homeworks mostly focus on simulation works. Okay? And quizzes will be some calculations and basic understanding of the materials being taught in class. Okay? Any questions? Now, I'm sorry if I didn't have the stickers prepared today, but you can probably give you a sign sheet or something. But if you have any questions, you want to raise any questions? No question today. Okay, so what I wanted to do is add a few. The other thing I wanted to probably discuss is that I will be sending these materials online, uploaded to e-class platform. And, but aside from today, I would then use the Blackboard for writing because it turns out that it will actually slow me down and then we can talk about more details. So I think from next time, aside from today, we're going to use the Blackboard for most of our discussion. Okay? So let me see how many pages I need. Okay? So before we actually dive into the introduction part of today's class, I wanted to basically give you some background as to what are the basic things I would like you to take away in this class. So the basic content of this class, I briefly go through that, but one is, of course, device physics. We're going to spend about maybe 1/4 of a quarter of the class. We're going to talk about device physics, but this will be in a very, very short or concise version of the discussion of device physics, just so that you have a basic understanding of how semiconductor devices functions and what are its key aspects and its operation mechanisms. So we're going to go through it maybe 1/4 of the semester. And then the second thing is that then we're going to talk about what we call the fundamental of circuits. So this is like understanding, you consider yourself an architect. So if you wanted to be an architect, what you do is that you understand the basic form of houses. So there are different types of houses, flat houses, ranch houses, or single level or two-stair houses. So there are various types of houses for different functionalities. So this is the same things is that we'll give you a basic concept as to if you want to construct a certain function in processing signal, because what's the purpose of circuit? The circuit is to process electronic signals. So once you have these electronic signals, how do you want it to have a particular functions, and what are the type of circuits that you can use, the type of structures that's being known and being discussed or being analyzed. So how do you know these basic, called the basic structures? And also, how does one analyze these basic structures? How do you evaluate whether this is a good design or not? So that type of things will be discussed in this fundamental part of the circuit introduction. And then I'm going to do some one of the other things that we're going to practice a lot is the basic understandings, or I should say skills, or analyzing method. As I said, how does one analyze a circuit? If I give you a circuit, the first thing you want to do is that you want to identify what is the purpose of this particular architecture or particular structure. And the next thing is that you want to understand how does one analyze it. There's a special, there's tools or methods that allow you to simplify way of viewing this type of circuit. So we're going to talk about that a little bit later today on the equivalent circuits. Well, we're going to use something called equivalent circuits a lot. How does one construct an equivalent circuits or equivalent view of circuits allow us to further go down in more complicated circuit structures or more complicated blocks, a combination of circuits. And then, of course, you wanted to have tools. You have to learn tools for analysis. As I said, understanding these models, tools of analysis including SPICE, you have basic rules of circuit analysis, circuit theories, and then we're going to do something called this. We're going to talk about a lot more on SPICE model, device model. Anytime you build based on models. So when you do design, you assume that this brick will hold certain strengths or it will have certain weight. So that's based on a particular model. So there's always deviation from models, but by having these models allow us to evaluate or project what will happen in your ultimate design when the circuit is actually being built. We're going to talk about that process a little bit when we talk about integrated circuit design and processes. Okay? So these are the basic contents that I think, or the basic skill you should expect yourself to learn throughout this, through this class. Okay? So there are basically two parts. I'm going to summarize a little bit. So now we'll consider part 1. That's chapter 2, 3, 4, 6. So, and that would include mostly on the device side. So before we actually start, we'll have to talk about a little bit on semiconductor physics and how these physics links to device characteristics. So how does it determine how when you apply a different voltage on the devices, its corresponding current responses? So the linkage between device physics and device performance or behavior. And then, of course, we're going to talk about specific devices. We're going to start with the most simple one, which is a diode. A diode consists of just two types of semiconductors. We're going to talk about type of semiconductors and how does the construct of this materials will then result in different performance or different characteristic of devices. So we're going to talk about devices, two types. One is the diode, the other is transistors. So, and of course, if you look at a circuit, it will be constructed with either diode, transistors, and what else? So does anyone want to try? Typically, this is referred to as, transistors are typically referred to as active device. So if you want to construct a circuit, aside from active, what is the opposite of active? Resistor, that's called. So you want to add resistors and also what else? If you ever, I think most of you have taken, I don't know, what else? Circuit theory, there's resistors and capacitor and inductors. Yeah, correct. So RLC, CL. So this is typically referred to as passive component. So if you're ever in the stock market, you know that they say there's a section of passive component. They're actually making passive components. Okay, so that's the LRC component in integrated circuits. So these are, even though we call it passive components, it's also very critical in electronic systems. So you combine those, and then we can make circuits. Okay, so that's part 1. So we're going to move on to part 2. Change the color. So on part 2, we have chapter 5 and 7 to 11. So first of all, we're going to talk about how to analyze I'm missing once a circuit in its DC form and AC analysis. We're going to do something called a small signal approximation or small signal model. So we're going to start by, if you're doing, I think most of the circuits we're going to discuss, and as I said, if you talk about electronic courses, typically there's the analog part and there's the digital part. So digital part is probably at the end. For this course, we're not going to touch on digital circuits. You need to take other courses to address digital circuit and digital logic gates. But so for analog circuits, what happened is that your DC analysis will affect your AC analysis, meaning that where you stand will affect your performance when you dance at this particular locations. So we're going to talk about that a little bit more. So we're going to talk about what we call the operating point. The analogy is that if I'm dancing on the stage, I want to find a starting point. So operating point is the point where I want to stand, and then it would actually make my performance the best. So make sure that I don't want to stand at the edge of the stage, because when I dance, I might fall out of the stage. So on the stage, you find the best point when you want to make a speech, for example, if you're not moving too much, but still you want to find a place to stand. So that's called a DC analysis, meaning that you determine where you're going to stand. How do you place yourself at the particular location? That's called the operating point. And then after you stand at a desirable point, the next thing you want to do is that you start singing or you start dancing. So that's you want to convey the signal. So that's the small signal analysis. We assume most of the time, why is it small? It's because we're not assuming that you're making big moves. You assume that you don't move too much. So that's called small signal analysis. You want to understand how your signal is being conveyed through the system at this particular point. So the point is that if I'm standing at a different operating point, I might have different small signal performance because the light shine on me is different. And when I stand at this operating point, point 8 or point B or point C. So that's how we're going to introduce the concept of designing. Aside from designing the stage or designing your circuits, you also need to design where you want to stand and why you want to stand there. What is the performance index you're pursuing? So we're going to talk about that a little bit on how does one evaluate whether the circuit is good or bad. There's various aspects we need to consider. So the second thing, of course, we're going to do something called a single stage. You start with single. So you want to build just a flat house at the beginning. So single stage circuits. So once you have the single element learned, you understand each of this single stage amplifier, how does it function, and then you can combine them together. So the combination part will be something called a cascade. You want to build a second story house. So that's the cascade structure. And also we're going to talk about supporting systems called the current mirror. That's mostly for biasing system. We're going to talk about that a little bit. And then lastly, we're going to talk about op-amp circuits. amplifier circuit. And maybe multi-stage. So you can then, once you have the basic understanding of how to stack it up or chain up your circuits, so we're going to talk about multiple stages. Other than single stage, you have multiple stage. And also we're going to talk about something, one of the key elements called a differential pair. Okay? And then lastly, we're going to talk about what we call the frequency response. So frequency response is just an index as to how fast or the bandwidth of your circuit. So this would then give you the bandwidth. And also index is a speed of the circuit. So how does one analyze the frequency response of different circuits? What are the key elements that affects the frequency response? If your bandwidth is not enough, what are the possible solutions that exist? That's how you evaluate your either the design or either the functionality or the technology. They are all linked together. So these are the things we're going to cover. And then lastly, I want to add a page. Even though we're at our starting point of the class, but I wanted to make sure that you understand where you're at. So you start with circuit theory courses on, I think, let me ask you, and for those of you who have taken circuit theory, please raise your hands. Circuit theory, 电路学，上过电路学举手。没上过举手。因为大家都上过 ，OK. Just want to make sure. Yes. 有人没上过吗？ Okay, anyway. So you start with courses like, is it called circuit theory? I don't know. So, did I spell it right? It's fine. I'm not sure I got the number right. But then you start with circuit theory. You have a basic understanding of how to analyze a simple circuit when you construct with mostly passive components. And then we're going to come to microelectronics. This is the course you're taking. So as I said, this is a fundamental course. This is microelectronics. This is, I don't know, course number. Something like that. Maybe I might got it wrong. So this is the course we're taking now. So in the future, if you're interested in further understanding of digital circuits, so there's digital circuits, as I said. So that's the EE3230. I just want to make sure I got it right. And then, of course, you wanted to do analog, more discussion on analog circuits. So there's analog circuit. That's E3235. And then if you wanted to learn more on devices rather than circuits, I should spread it out a little bit. If you're more interested into technology, then I will strongly encourage you to take solid-state circuits. I'm sorry, solid-state devices. 固态电子。I teach that in fall semester. So if you're interested in understanding more on device physics, how device functions, or the technology impact of devices, then that will be a course to take if you're interested in that. as I said, in the device and physics part, we're going to be very limited because we only have like 2 to 3 weeks times of discussion.